Here with you, well, Z-dawg and Mista Zed. If you've noticed, my hair has gotten even taller. I think by the next week I may have to wear a man bun. What do you think?
Yeah, we all need a haircut, buddy.
Oh my goodness. All right, so this reaction is the one that you would have in the notes pack about the lab that we're doing. So we've already talked about the reaction. This is a double replacement. And what we're trying to solve in this lab is the theoretical mass of the precipitate. So what we're going to be solving is the strontium sulfate. In this lab, we are mixing two solids together, 2 grams of strontium nitrate, which is like a white powder, and we've put it in solution, and we've mixed that with 2.56 grams of copper sulfate pentahydrate, which we've put into solution as well. Now, we are going to be using something called the limiting reagent. So this substance, this copper stuff, we've done the calculation to make sure that there's so much of it, we will have excess left over. We want to use every last mole of this limiting reagent so all of it reacts. It's kind of the more important thing. When you're making a sandwich, it's okay if you have excess lettuce, but you don't want to have excess cheese. I don't know if that's what happens in your house, Z-dawg, is that correct?
Yep.
Yeah, you don't want, like, who cares about a little bit of lettuce, but if there's bacon, you're not going to throw the bacon away. No, you're going to, okay, so this is the bacon, this is the lettuce. So these are the two substances that we are going to link together. Now, previously we've already practiced a little bit of Stoich, so this is just going to be a quick recap, okay? All right, so I'm going to be finding the mass of the strontium sulfate. And because we're comparing these, it's a 1 mole ratio. We have 1 mole of strontium nitrate to 1 mole of strontium sulfate, okay? We are not using the other two entities, so they're not going to be part of our reaction. In fact, this is excess. We don't even need that in those numbers. They're not helping us. And this, we're not even caring about that. Okay, so where we start with is we start with trying to find the mass of the substance. So we're solving for grams. Our final unit needs to be in grams, but not only does it need to be in grams, it needs to be in grams of strontium sulfate. So we're going to start with the grams of strontium sulfate on top. Now, I was a little lazy, as you can see. I didn't put the stuff in there. That's gram strontium sulfate per mole strontium sulfate. So that's what I'm going to start with. 186.69.
183.
Oh, 183. Thank you. Sorry. 183.69 grams strontium sulfate over mole strontium sulfate. Okay. And so that variable's used, or that thing's used. I can't use it again. It's gone. Then I need to get rid of moles strontium sulfate. I can't use that mole because that mole belongs to this substance. So I'm going to be using the mole ratio next. And to get rid of mole strontium sulfate on the bottom, I'm going to flip this. So 1 mole strontium sulfate on top over 1 mole strontium nitrate. Okay, and now just for good syntax, I'm going to go back through here and I'm going to put in my states. Okay, so mole strontium sulfate cancels. Now my last two variables, I need to get rid of mole strontium nitrate. So that's the mole I'm going to use, and I'll flip that around. I'm going to run out of room here, which I always do. Okay, so flipping the molar mass, mole strontium nitrate, over 211.64 grams strontium nitrate. Okay, and I'm going to get rid of the grams with the 2 grams right there. 2 grams strontium nitrate. And had I planned this a little bit better, it wouldn't be so smooshy. Okay, hopefully people at home can see that. Sorry, Z-dawg. It's a little bit smushy. Okay, so I'm going to go 183.69 times 2. Okay, that's the top divided by the bottom, which is 211.64. Okay, I get 173.5 blah 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 blah. What should we round this to, Mr. Zielinski?
3 sig figs.
3 sig figs.
1.74.
1.74. So we did all of this mess to get 1.74. If everything goes right in this lab, whoop, that's a gram. If everything goes right in this lab, we should get 1.74 grams. And Z-dawg is going to come up next with the setup to actually get this lab going.
Hey, Chem Stars, we are back. We got the Z-dawg here. I got the Chem Mojo today. I'm so happy to see you. What we are reacting is copper 2 sulfate water 1/5. As Mr. Zed outlined, we need 2.56 grams. This is our excess reagent. We combine that with 75 milliliters of distilled water, stirring it up, getting a solution. In order for ionic compounds to react, they typically have to be in solution. You cannot get much of a product reacting two solids together. Rare occasion it happens, but that's unusual.
It's those ions, guys. Remember the total ionic reactions that we were just finished doing?
Making electrolytes, making reactions. Similarly, I've got 2 grams of strontium nitrate. It's a white solute, as you can see. Our limiting reagent, all of it's going to get reacted away. Also combining that with 75 milliliters of distilled water, preparing the solution.
That does not look as tasty as the other stuff.
Raspberry Kool-Aid versus water.
Lemonade?
Lemonade, baby. We react the 2 solutions together, pouring one into the other.
Ooh.
And as you can see, the mixture becomes opaque. We have a cloudy solution. Very important to get every little portion of a mole out of our reaction container.
I've actually zoomed in on that little bit that didn't go.
Great camera action there. So rinsing. We want to get a complete reaction. We don't want any excess reagent left over. If a chemist has time, they can leave the reaction settle and precipitate out. I've done that here. This is a previous experiment, a setup, and you can see that we have strontium sulfate precipitate at the bottom, and our copper nitrate filtrate, our other product, is here at the top. An additional technique is called precipitation completion, where you take additional excess reagent and with a medicine dropper, you add carefully drop by drop of the excess reagent to your solution, and you're looking for the formation of additional precipitate. So if the reaction was incomplete, we would see white precipitate form here at the top at the interface between the 2 solutions. However, you can see that there is no cloudy mixture forming here at the top, so it appears as though that we do have a complete reaction between our excess reagent, the copper 2 sulfate water 1/5, and the sodium nitrate. On to Mr. Zed and our next step.
All right, so the Z-dawg did a great job mixing those 2 chemicals together and making sure we didn't lose any precipitate. We need to weigh the filter paper because what we're going to be doing is putting the filtrate and the filtrate through this and precipitating. The precipitate will be left behind. If we don't weigh the filter paper ahead of time, it's going to have a bunch of solids stuck on it, and you're going to have to scrape that off, and you're still not going to get a good reading, because if we weigh this today and then we weigh it tomorrow with the precipitate on it, you can subtract the 2. Brilliant. Okay, so this looks like it's I can't read it from this side, 0.6 something?
0.69 grams.
0.69 grams. Okay, so
0.7.
it's very important to write that down, or write it on the filter paper. That works too. Okay, folding the filter paper is a little bit of chemistry or origami. This is how I do it. Maybe you do a different Z-dawg. We'll see if we're the same. So I fold it in half to make a half pizza. and then I fold the pizza in half one more time, and now you've got a slice of pizza. Holding the very pointy tip of the slice of pizza, you can open it up into a cone to filter. Now this, if you try and put this in the filter paper, it sometimes just shoots right back out. So what I like to do is just wet down, give a little squirt and wet down the funnel, and you maybe have to get the whole thing a little wet so it's sticky, because you don't want it to be lifting, because you might pour it in there and pour the chemical through a crack, and then you're not going to capture stuff. Okay, so this is the awesome solution that the Z-dawg got ready. Look at this. That's the one he got ready. This is the one that he let sit. So he's good. So I'm gonna do something called decanting, which I'm gonna try my best. I'm not very good at this, but what it does is it allows you to get the liquid into the funnel without clogging up the filter paper. So I'm just gonna try and get most of the liquid through by doing this technique. Now you can live dangerously and do this a lot higher, but I'm not great at this technique, so I stay kind of low. I don't know, what do you do, Z-dawg, there?
Just like that.
Yeah, you don't try and go from the side and use the hydrophilic forces to cling to the thing. I've seen people
the glass,
do that.
yeah, that can be done.
Yeah, that's fancy.
Main thing is not to overflow our funnel here so that we lose precipitate again.
Right. If you go above the paper, then it's just going to go down the other side of it and you're going to lose it. I've done that before. Not paying attention, you overfill it and you feel like a silly person. Okay, here we go. Round some more. Now, I will be fast forwarding this when I'm editing because this is a boring part.
Yeah, usually the filtration takes the bulk of the class period. If you were here, Chem Stars, you would be doing a quiz. Well, this painful process of filtration occurs.
But with the magic of digital ed, this is going to take all day, Z-dawg. Look at all of this to do. Okay, I'm going to do this one more time, and then I think we'll just jump to the end. You can see we'll also have to get all of that precipitate out.
And then rinse the flask, or rinse the beaker as well to get it all out. So one more time with the awesome decanting technique. So look at that go. Oh, it's so cool. Now you got it. Okay, I'm getting better. Doing it this way is a little bit more controlled than just yeeting it into the funnel, so that's why we use this method, right? You just dump it like this, you don't have as much control. Yeah. Okay, go ahead. Filter will get clogged, and it will take you just as long or longer by pouring it quickly anyway. Right. So we're going to do some magic and go right to the end, where all of this has been poured in the filter, and it's filtered all the way through, and dried overnight, because that's another 45 minutes of work, right? Okay, thanks.
6.5 hours later.
Okay, we're back. And as Mr. Zed said, he has filtered off the entire filtrate. Remember from Science 8, filtrate is what flows through the funnel. And that's our copper nitrate, as you see from the balanced equation. We've been careful not to lose any precipitate over the sides of the filter paper. Now we are being really careful to rinse and get every little bit of precipitate into our filter. That's where we can use this funny little device called a rubber policeman. It's kind of like a spatula at the end of a stirring rod. We'd let the precipitate dry overnight, just like the cooking show.
Ooh, be careful, Z-dawg.
Yeah.
How many kids' hopes and dreams shatter at this point?
Right here at this step. Just like the cooking show, you smell what the Z-dawg's cooking. Overnight, we have dried our precipitate. Can you get a close-up in on this?
I can do
Mr.
so.
Zed?
Oh, there we go. Well,
we have a light blue white fine powder onto our pre-masked filter paper, which was 0.69, 0.70 grams. Very carefully, we transfer this over to a balance scale. If you can use a centigram balance, measuring with 2 decimal places, so much the better. And Mr. Zed, you'll have to read 2.34 grams, folks.
2.34, do you want me to verify?
2.34
Got that?
is the mass of our filter paper plus our precipitates.
Right. Both. Whoa. Sorry, bad camera guy.
We'll subtract from that the mass of the filter alone.
Can you imagine how much of a pain it would be to scrape all of that off to try and get every little flake of it?
Yeah.
Ugh.
Gotta be careful to get good results. How's that look, Mr. Z?
Yeah, 164, sure.
1.64 grams. Folks, this is our experimental mass.
Whoop.
As Mr. Zed calculated in the beginning, our theoretical is 1.74 grams.
Oh, dang.
We're pretty close.
That is pretty close. That's pretty close.
Mr. Zed would also refer to this as a lab value, lab in theory.
Oh yeah, that's what I do.
Experimental
Should I stop
in
doing?
theory.
Should I stop doing that, Z-dawg?
No, that's just fine.
Yeah, I call that the lab value.
There's two calculations that we can do following this up. One is a percent yield. Hey, it's just like you calculating your score on a quiz or a test. You take what you got divided by the total times 100. We'll do exactly the same thing here. Lab or the experimental divided by the theoretical. Mr. Zed on a calculator, please.
Oh yeah. Okay. Calculator is over by you actually. I got it. Sorry. Okay. Okay.
1.64 grams.
164 divided by 174.
1.74 times 100,
Yeah.
everybody.
Yeah. It's 2 3 sig figs. 94.3%.
94.3%.
Smoking. It's pretty good.
Remember, any value within 10% is deemed acceptable in a high school lab, considering the equipment that we have to work with.
What is it? What is it acceptable in university?
Oh, very stringent values there. You get marked on your results there.
Mine was in university. Mine was within 2%.
Whoa. Another calculation that's sometimes done is a percent difference calculation. That's the absolute value of the lab value or experimental minus the theoretical divided by the theoretical times 100.
Remember to subtract that first part. Some of your calculators might give you a gobbledygooked answer if you don't do the top calculation first.
Right. E.T., like Z-Dawg's favorite all-time movie, Mr. Zed. E.T. E.T. And what we would get here is 1.64 subtract 1.74 divided by 1.74.
Yeah, it's basically 100 minus what we calculated up top there.
Exactly.
Yeah, 5.75 roughly. Or no, that's right. 1.64 subtract 1.74 divided by 1.74. 5.75.
5.75%.
Yeah, it's rounded
So
differently.
notice everybody that percent difference plus percent yield always gets you right around 100%, give or take rounded values.
Yeah. Yeah, we rounded a bit. It's pretty good. 5% error.
Yeah.
5 and a bit percent
fantastic.
difference. There are many places in a little lab like this you could have catastrophic mistakes.
And we mentioned some of them, of course. So losing your precipitate here as it gets transferred to the scale, not fully rinsing out your reaction beaker, overflowing your funnel with your mixture. All of these are ways that can compromise and lower your results. thanks for tuning in to Lab 7.2, where we're looking at testing gravimetric stoichiometry.